Hello, everyone. Well, the title of this is Finding Key Opinion Leaders in the Medical Specialties. My team is Lavanja, Mohammed, myself, and Hossein. The sponsor is McCann Health. McCann Health supports a pharmaceutical company in finding key opinion leaders. Key opinion leaders are members of the academic community that have advanced knowledge in some specific medical issue. They are influencers in social media terms, and they are important to pharmaceutical companies because they sometimes hire them as consultants, and having the right people for the right work is essential for success. McCann Health has traditionally performed this research by browsing sources and collecting information in what is called a desk research. And the disadvantages of this is they can only analyze a small number of people. It is hard to understand how these QOLs are connected, and it is, of course, a time-consuming task. The solution that we propose is a semi-automated method to efficiently extract QOLs in medical areas. We are using API and web scraping tools, and also some manual collection. Our most important work is to feature engineer some, for instance, a domain-specific scientific impact factor. We're also building a network of QOLs for finding new QOLs, or also to figure out the number of connections a person has. To be able to run the QOLs, we are using a weighted sum from several aspects. The value that we bring is that we can cover a long tail of QOLs. But what that means is that we can analyze a large number of people, which can be difficult to keep track. We are automating some steps of the searching strategy, and we are improving because we are doing first a breadth first approach, and then they can follow with a deeper, more detailed searching. This makes the time and human resources use more efficient, and we can bring a unified view of the scientific, social, and also the political impact of a researcher. In this work, we analyze 3 therapeutic areas, but this method is adaptable to other areas as well. So this diagram shows the general overview of the solution. We'll start with a list of names, which we call seed names. They can be from the desk research, or we can also generate these seed names from the literature. And for these people, we analyze 3 different aspects. First, the political, which is related to the leading positions in relevant scientific societies. Also the social impact. This includes social networks, but also the number of mentions a person has been mentioned in some news or in some local or international news. For these sections, we use some name entity recognition algorithms to find out some names. For the scientific aspect, the ranking of the QOL is based on the publications. From this set of publications, we can extract features or statistics like the H index or the number of publications or citations. And we can also create a collaboration network of how these people are collaborating in different works, scientific work. This network can be useful also for ranking. You can see which person is very well connected, and you can also find new names which might not appear in the first round of this analysis. All of these aspects, we put them together in a weighted sum, and we rank these names. We are providing a file which is interactive for the user. So depending on the analysis, you can have more weights for the publications, or more weights to the social or the political. This is an example of fiction person for a fiction person. So you can have all of these scientific features, specialization, publications. You can also have some features about social and political, and also the position of this person in the network. So how well connected this person is. This is a video that shows a graph. In this case, it's around 1,000 nodes. This is people collaborating in different papers. You can see some edges are wider. That means that these people are working in a lot of works. And also the size of the node represents the productivity of this researcher. Based on this graph, we can have in future work more insights, you can see more connection, and you can find non-obvious patterns from the data. From a pool of around 1,500 researchers, we obtain these total numbers. So for instance, in each area, we started with 30 names. These names were provided by the desk research, so these were done manually. And from each of these 30 or 40 names, we were able to extract all of these names. Like in total, it's about 700 names. This is the team. So Lavanya is a PhD candidate in astrophysics. Mohammed, a data scientist at IBM. Myself, Hope Quiroz, a PhD in computer science, and also Hossein. So we have vast experience in data collection and data analysis. And well, we'd like to thank PiSchool and McCann Health for their support in this project.